Class, today's lesson is on 4-1, congruent figures. You should be on page 218 in your book. So make sure you're on that page 218. Okay. So we're going to start off with the get ready. All right. If we look at the get ready, we see that we are working on a puzzle here. All right. You almost finished your puzzle, and except for a few pieces of the sky in the puzzle, place the remaining pieces in the puzzle. So what I want you to tell me is, how do you figure where these pieces go at? How can you figure out where these pieces belong in that puzzle? Anybody? Chantel.
By their shapes.
By their shapes, exactly. So what about the shape? If you look at this shape, what would you do with that shape in reference to the puzzle itself? Cain.
I try to, look for the correct size around the thing, and you stick it in.
Exactly. So in other words, what Cain and Chantel was saying is that they will look at the size and the shape of each of the pieces of the parts, and then they will match it up to the empty spaces there to get it. So this leads us into what we're going to talk about today. Today's objective is to recognize congruent figures and their corresponding parts. Okay? So again, we're on page 218, and we're going to start right away, and let's go. Okay. So when we're looking at figures and we want to see if they're congruent, and what does congruent mean? Anybody remember what congruent means? Anybody?
That they're equal.
That they're equal. Equal in what? Not only in shape and size, but also if we had, all right, if there was a certain measurement to it, it will also be equal in measurement. Good job. But what if we didn't have any measurements for those? What if we had no numbers or anything? We just had two pieces. Like say we have these two pieces right here. Are there ways that we can figure out if they're congruent, meaning the same size and shape and equal? Yeah. Yes. So if we look at this, there's one thing that we can do is we can slide the pieces on top of each other and match them up and see if they are congruent. You see that there. Another way we can do is we can turn the piece. In this case, we can turn the piece this way, and we can match it up, and we can see that these two pieces are congruent. And then the last way is a flip. And I'm not sure that I'll be able to do the flip on here. Let me see. And let me get to the flip, transform, and we'll flip it about the y-axis. Oh no, it went the wrong way. So let's try this again. We'll do this one right here. And we'll go back to our transform and flip about the y-axis. And it still didn't work. And here we go. Let's try it again this time. All right. So we'll transform and flip about the y-axis. It's not working, y'all. But we run into problems all the time. That's part of life, right? There we go. All right, good job. So we see that there's different ways that we can see if two pieces are congruent. We can slide them on top of each other, we can turn them, or we can flip them on top of each other, okay? That's if we didn't have any measurements or anything to tell us about the shape. All right, this leads into our first definition, congruent polygons. Congruent polygons have congruent corresponding parts. They're matching sides and angles. And when you name congruent polygons, you must list corresponding vertices in the same order. Right now, I need y'all to write this definition in y'all notes. All right, Tamber. If we look at this polygon, can you tell me what are the vertices for this polygon right here?
A, B, C, and D.
What about the second figure? What are the vertices for those?
E, F, G, and E.
Good job. All right, this leads into our first definition, congruent polygons. Congruent polygons have congruent corresponding parts. They're matching sides and angles. And when you name congruent polygons, you must list corresponding vertices in the same order. Right now, I need y'all to write this definition in y'all notes. All right, Tamber. If we look at this polygon, can you tell me what are the vertices for this polygon right here?
A, B, C, and D.
What about the second figure? What are the vertices for those?
E, F, G, and E.
Good job. When we look at this definition, congruent polygons, if we look right here, we see A, B, C, D, which names this polygon, is congruent to polygon E, F, G, H. Now, what that means is that it's giving in corresponding order, and that is very important when we're talking about congruent polygons. Now that you have your definition down, let's look at what that definition means in this example. So if we look at these two polygons, as Tamber said, we have our vertices A, B, C, D, and E, F, G, H, and with those vertices and those points, we can create segments. So if we look, we see we have segment AB, and it tells us that segment AB is congruent to segment EF. Now, what's special about that or unique about that is that the order in which it's given. We see that we have segment AB going from left to right, and we have segment EF going from right to left. So what that means is that we're naming them in corresponding order, and that's very important when we're talking about congruent polygons. We have to name them in corresponding order. So again, when we look at the remaining segments of the two polygons, or the congruent polygons, we see that segment BC, which goes from top to bottom, is congruent to segment FG, which goes from top to bottom. Then we continue on with segment CD, and then is congruent to GH, and then last but not least, segment DA is congruent to HE. Let's look at problem number 1, finding congruent parts. If HIJK, which is this polygon right here, is congruent to LMNO, the second polygon here, what are the congruent corresponding parts? So again, when we list corresponding parts, we notice that it's listed as HIJK and LMNO. And again, that's very important when we get into naming the sides and angles that are congruent to each other. So if we look right here, we see that HI is congruent to LM. And that's the order in which they are given when we talk about the polygons of being congruent. HI is congruent to LM. We also see that IJ is congruent to MN, and it's also the same order. IJ is congruent to MN. That's the order in which they are given. And we continue on with JK is congruent to NO, JK to NO, and KH is congruent to OL. Also, we have to look at the angles. They are also given in corresponding order. Again, H is congruent, or angle H is congruent to angle L. Angle I is congruent to angle M. Angle J is congruent to angle N. And angle K is congruent to angle O. Okay? Now, let me ask you a few questions to see if we truly understand this. Tariana, how can you use the order of the congruent statements to identify the corresponding parts? How can you do that?
By looking at the vertices listed.
And the vertices?
Listed in corresponding orders. So the sides can be listed in the order they appear in congruent statements.
Chantel, what can you do with the diagram to help identify corresponding parts for this one?
You can redraw one of the figures so that the orientation is the same for both figures.
Good, yes. You can, and again, that goes back to what we talked about earlier when we opened up the discussion. We can slide the figures, we can flip, and we can turn. Good, Kaim and Tariana. So that's what Chantel was talking about. She would redraw this figure and put it on top of this other figure to make sure that they are congruent. Good job. Okay, now that we finished the first problem, that leads into the guided. I need y'all to work individually and work the guided. good, Kaim. Look like Tarion is almost done. You done, Tarion? All right, y'all continue working. And I'm gonna have Tarion. Tarion, you can come and work this one on the board, the first guided. What color you prefer?
Purple.
Purple? Give you that purple. Here's the purple. There you go. And then you can just the angles over here if you like. Just on this one. It's okay. It's all right. Okay. Thank you, Tarion. Good job. All right. Anybody had anything different than what Tarion put on the board? She has segment WY is congruent to segment MK. Segment YS congruent to KB. Segment SW congruent to VM. Angle W congruent to angle M. Angle Y congruent to angle K. And angle S congruent to angle V. Anybody had anything different than that? No? All right, good job. We have ACT coming up, and so in order to get prepared for ACT, we're going to do some problems with ACT. Work some problems with ACT from the ACT study guide. So let me give you your books right quick. And here we go. This your group. And so turn to the math portion of it. We're going to start with problem number 1. So let's turn to the math portion. There we go. All right. And that's on page 24. Okay. Page 24. So we start with problem number 1. Now, what I did already is I took y'all names down. I paired y'all off in groups. So what we're going to do is we're going to have a little competition. Okay. Now, once you do the first problem, the first group that comes up with the answer and demonstrates that they got the correct answer, they will get the points, okay? So right now I need to begin. We're starting with problem number 1, and you can start. You got it?
Yeah, we got it.
All right. Come on, Deontay. Deontay and Kaim, sit in here the answer. Let's see. Here, Deontay.
So if there are 150 people,
We're talking a little louder.
if there's 150 people, we just want the one with A and AB blood type. We gotta add the amount of people with A blood type, which is 67.
Okay.
67. And the people with AB blood type, which is 6.
Okay.
So then that's gonna equal 73 people with A and AB blood type. And then you gotta divide that by 150. And that's gonna be your answer to average to see what's the chance that you're getting a person with an AB blood type. And that has to be.
Good job. All right. So that's what you should have came up with. The answer is 73 over 150. The probability of choosing someone with A or AB type blood would be 73 out of 150. All right, this is your last problem. Trinice says she has the answer. Let's see, in fact, if she did get the correct answer. If not, remember, you will have a chance to steal if she doesn't get the answer correct. Okay? Good job. That is the correct answer. Good job, Trinice. All right, so if we look at it, it does tell us that for each ½ inch, it represents 18 miles. We have 2½ inches between the two towns. And we can see what Trinice did. She took 2½, she divided by a half. That gave us 5, meaning that they had 5 segments of ½ inches contained in that 2½. And she multiplied that times 18 because every ½ inch represented 18 miles. So she got 90 miles. Good job, Trinice.
Thank you.
All right. As y'all close out and continue working, remember your homework is Math Excel, homework 4.1. And next class period, we will have a quiz on 4.1. So don't forget that. Make sure you study on and do the homework so you'll be prepared for this quiz. I want you to continue working with the ACT prep. If you have any questions about the ACT prep, remember I'm free during lunchtime. I won't be free after school this upcoming week at all. But during lunchtime and on my off periods, which is 3rd and 8th period, I will be free if you have any questions. Other than that, just continue working until the bell rings.